everyone. This is H. Rahman from Agricultural and Food Engineering Department, IIT Kharagpur. I welcome you all to this NPTEL course on traction engineering. This is lecture 31, where I will try to discuss about performance of truck and its comparison with wheel. Wheel and truck, these are the two traction elements which are mostly used with the tractors. So you have to now compare which one will give you better performance. So the performance comparison will be carried out based on tractive performance parameters like motion resistance, pull, net traction ratio, tractive efficiency and slip. So these are the parameters based on which we will try to compare the performance of a truck with wheel. So to carry out this kind of study, what we have done is a power tiller is fitted with a truck, rubber truck, and the power tiller is fitted with a normal wheel, and their performance will be compared when they are operated under same operating conditions. So this is the soil condition where the soil is sandy clay loam, sand, silt and clay percentage are 57.1, 19.9 and 23%. Then particle density is 2.65 gram per centimeter cube, and then cohesion is 11.76 kilopascal, adhesion is 7.66 kilopascal, and the angle of internal friction, that is around 22 degrees. These are the specifications of the power tiller. One thing which we try to maintain is the mass for both the conditions. Both the conditions means the wheel as well as truck should be same. So that we kept as 530 kg. Then this is a single cylinder engine, a 4-stroke diesel engine. Width of the truck is 0.15 meter, contact length is 0.78 meter. Diameter of the idler wheels is 0.34 meter, diameter of the rear drive wheel is 0.55 meter, and diameter of road wheel is 0.11 meter. Then the logs which are present in the truck is similar to the logs which are present in the wheel, and the wheel size is 152.4 by 304.8, and this is a 4-ply rating, and the inflation pressure maintained is 147 kilopascal. These are the instrumentation which are used to measure these performance parameters. The performance parameters includes your wheel slip. For measuring wheel slip, you require theoretical speed as well as actual speed, and both are measured with the help of a proximity sensor, and the proximity sensor is attached to the rear axle, so that will give you velocity of theoretical velocity. And another proximity was attached to a towed wheel, which is an extra wheel, so that will give you the actual velocity. So knowing the actual velocity and theoretical velocity, we can calculate slip. And the other major component is the load, the pull which is applied, and the pull which is required to tow the tractor. So those are measured with the help of a load cell, which is shown in this figure. So a load cell and proximity sensor, the output data are stored in a computer through a data acquisition systems. So these are tested in the field. The procedure which is followed are: first the travel speed of the load tractor. Initially it was adjusted by gear and throttle so that it matches with that of the power tiller. Here the tractor will be used as a pulling equipment, we can say. And then the drawbar pull was applied by adjusting the speed of the tractor. So power tiller, initially speeds are same for both the tractor as well as power tiller. Later on we tried to change the speed of the tractor, because the power tiller, whether it is attached to a truck or whether it is attached to a wheel, that will be tested. So that's why to find out the pulling ability, we varied the pull of the, we varied the speed of the tractor, which is called the load tractor. Then by throttling down the load tractor, the load is increased on the power tiller. And if you reduce the throttling further, it will further reduce. That means load will be increased. If you increase the speed of the tractor, then load will be decreased. So that is the way we tested the power tiller when it is fitted with trucks or wheel. And each test, whether it is fitted, whether the power tiller is fitted with truck or whether it is fitted with wheel, this was carried out on a length of about 25 meters. It was a long span, and it was repeated thrice, so that whatever data we get, that will give you more or less an average experimental data with lesser experimental error. The tests were conducted for different pool values up to 4 kilonewton. These are the outputs related to motion resistance. The blue line was for wheel and the red one is for truck. These tests were carried out for 3 different soil conditions. One is 250 kilopascal cone index, that is soft soil, which is related to 250 kilopascal. Then there is a medium soil where the cone index is 500 kilopascal. There is a hard soil where the cone index is 1000 kilopascal. In all these 3 conditions, what you can observe here is rolling resistance of a wheel is more than the rolling resistance of a truck. The reason is truck has longer contact length, it has higher contact area, so obviously the contact pressure is less, so compaction is less, hence rolling resistance is less. So that could be the reason why the rolling resistance of a truck is lesser than the rolling resistance of a wheel. Now, if you look at the soil conditions, if you look at, then the harder soil gives you lesser rolling resistance. That means you are getting only 530 Newton. Whereas in soft soil it is giving you 935 Newton. Same is the case with wheels. On hard soil it is giving you 620 Newton, and soft soil it is giving you 1012 Newton. The reason is very simple. A soft soil means more compaction, so more rot formation. Hence, more power is required or more force is required to overcome that rot, to ride over that rot. So that could be the reason. So when you compare at different soil conditions, that means 250 kilopascal, 500 kilopascal, 1000 kilopascal, you can see always the trucks are better than wheel. That means truck will require less power to overcome the rolling resistance. And with increase in strength of soil, the cone index values are as the motion resistance values are decreased. Whether it is a wheel, whether it is a truck, for both the cases, rolling resistance values are decreased. So in summary, what we can say is motion resistance of power tiller, when it is fitted with pneumatic wheel, it was found 8.2%, 14.8% and 16.9% higher than the comparable power tiller when fitted with rubber trucks. So in 3 soil conditions, for example, 1000 kilopascal, 500 kilopascal and 250 kilopascal, average cone index value. Both rubber trucks and wheels encountered higher motion resistance in soft soil, and the loss due to motion resistance decrease as the soil strength is increased. The next parameter is your drawbar pull. How much pull a truck or wheel can develop at different values of slip, starting from say 3% to 45%. Again, these are carried out for three different soil conditions. One is dropper pool, one is the soft soil, which is 250 kilopascal. The other one is medium soil, which is 500 kilopascal. The third one is hard soil, which is 1000 kilopascal. So if you look at these curves, whether it is a wheel, whether it is a truck, both the trucks and nets are giving you similar output. Similar output in the sense the nature of output is same. It is fast increasing at a faster rate, and then it is slowing down. Same is the case with truck. And same trend is followed in different soil conditions. However, if you look at the two graphs, there is a difference in the pool which is developed. The truck is developing much more power or much more pool as compared to your wheel. And this difference is decreased with increase in soil strength. So in brief, the dropper pool which is developed by the power tiller when it is fitted with the rubber trucks, it was 62.4%, 75.9% and 115.2% greater than that pool which is developed by the power tiller when fitted with standard pneumatic wheels in three soil conditions. So much gain was there. In case of soft soil, 250 kilopascal, we are getting a gain of 115.2%, more than 100%. Whereas in hard soil, we are only getting 62.4%. So softer the soil, better with the pulling ability for a truck as compared to wheels. Next is the coefficient of traction and the tractive efficiency. For both wheels as well as truck, this has been plotted for different soil conditions. One is 250 kilopascal, 500 kilopascal, 1000 kilopascal. In 250 kilopascal, the COT value maximum is reaching. Initially it is increasing, then it is going slowly. The rate of increase is reduced and it is slowly becoming or nearly constant. This orange color and these are the two for COT, that means pool divided by weight. Whereas these two curves, the upper two curves, they are meant for tractive efficiency. The top curve is for tractive efficiency of truck, whereas the lower one is the tractive efficiency of wheel. Similar trend has been observed for 500 kilopascal as well as 1000 kilopascal. The maximum tractive efficiency which you got is 0.71 like that in case of truck, and this is possible in case of hard soil, whereas in case of wheel it is only 0.62 like that. That means 62% is the efficiency in hard soil. So in summary, what you can say, the maximum tractive efficiency which is developed by truck was 51.15%, 63.3% and 70.7% at the slip values of 16.8%, 11.85% and 9.96%. For average CI, that is cone index of 250 kilopascal, 500 kilopascal and 1000 kilopascal respectively. And as compared to wheel, this was only 38.7%, 55.7% and 64.3%, and the corresponding slips are 20.6%, 15.25% and 13.24%. That means at lesser slip values, we are getting more tractive efficiency in case of track. Whereas in case of wheel, the tractive efficiency obtained in soft, medium and hard soil, they are lower than the tractive efficiency which are obtained with the tracks. And the slip at which the tractive efficiency were obtained for wheels is around 20.6%, 15.25% and 30.24%. In all soil conditions, the peak tractive efficiency developed by tracks was found to be higher than that with wheels. And the other important thing is the peak tractive efficiency which is achieved by the tracks was at higher NTR values. That means higher pull to weight ratio values, and it maintained a higher tractive efficiency for a wider range of NTR values. Whereas wheels achieved the peak tractive efficiency at lower values of NTR, and the tractive efficiency drops off at higher NTR values. And peak tractive efficiency was observed to be higher in case of soil with higher CI, whether the power tiller is fitted with tracks or whether it is fitted with wheels. So we are getting tractive efficiency. If you look at this figure, we are getting tractive efficiency for a wider range of, that means this maximum from here to here, so corresponding to that, the pull to weight ratio is quite large, in the sense from 0.2 to 0.34, like that. So for a wider range of NTR, you are getting maximum tractive efficiency. So that is a plus point in case of power tiller when it is fitted with tracks. So in this lecture, attempts are made to compare the motion resistance, the pull, the tractive efficiency, and at what slip values you are getting the maximum tractive efficiency when the power tiller is fitted with a track or when it is fitted with a wheel have been discussed, and they are compared for 3 different soil conditions. So from there what we conclude is the track which is giving you better performance. Performance in terms of rolling resistance, in terms of tractive efficiency, in terms of coefficient of traction. The main reason is why the tracks are behaving or performing better than the wheels is the contact area. Higher the contact area, for the same load, the ground pressure is less, hence less compaction, hence less rolling resistance. Hence the thrust which is developed, that will consume only lesser amount of power to overcome the rolling resistance. Hence more power of the pull is available. Whereas in case of wheel, the contact area is lower as compared to tracks, and the ground pressure is more, hence more compaction, hence more rolling resistance, and the tractive effort or the thrust which is developed by the wheels are lesser than the tracks, hence net pull available is lesser than the net pull available with tracks. This has been discussed on the basis of some experimental data which are carried out by these last three papers which can be taken as reference. Thank you.